Oh, you're not even wearing your boots today.
Yeah, I'm wearing my thing.
Okay.
Where are we in front of me?
We're not making fun of anybody. Okay, in the word linear, what word do you see?
Line.
So today all we're worried about are things that are lines. Show with your arms. A line is a straight line. What did you say? I think I know what he said. I don't want to know. We'll just drop it. Okay.
What did he say?
Does the graph represent a linear function or a non-linear function?
Linear.
Wait, which one?
Non-linear, because it's a curved one.
Yeah. Is A a line? No.
What page are we on?
Like the third page in? Non-linear.
This is not even the right packet.
Not a line.
The next one, obviously,
Example 1. Oh.
is a linear function.
Yes, it is. It's a line.
My whole thing's out of order.
Do you need another packet?
No. This is out of order.
I don't think it should be.
I'm confused.
There you go. That's it. Right. A line is just a line. You guys know what makes a line a line?
Straight line.
Yeah, but what makes it a line?
A
A
line.
line with the arrows.
So like why?
The bar graph.
Because you want to.
Yes, it's constant. It's going up by the same rate, right? Otherwise, if it wasn't going up by the same rate, it'd be like, you know, like go all over the place. That makes sense? Okay. So that's what we have to figure out on the next part. So we're given tables, right? We'll go back. We got time.
We gotta go faster. I gotta watch that live.
Oh, we still have so much time. Plenty of time. Plenty of time.
Like, okay, so what do you guys think is gonna happen? It's only talk about.
You're not going to see anything different. Well, it's just say 4 shades.
Okay. So when you're given a table, we have to see if it's going up at a constant rate, right? So let's first check our x's. What are our x's going up by?
3s.
Whoa.
Oh. Can I go grab something?
Sure.
Can I go back
No.
after he gets back?
Yeah.
I forgot it somewhere across the school.
We're going by 3s, right?
Yep.
Okay. So that's constant. Now we can see what our y's are going by.
Going down by 6. So it's constant. So it's linear function.
Yep. Brian, do you need to move for notes?
Lord, I should have stopped.
Okay.
No, I was copying Brian.
Constant rate.
The next one isn't because underneath on the y-axis,
It's not going up by the same?
no, that's going up by 2, so the y was going up by 7, and 9 plus 7 is 16.
Yeah. Oh, now you guys have 4 to try on your own. Take a second, see what you think for those 4. Anyone need a calculator? Got a lot of calculator? I like calculators. You don't want one? No. That's your screen. That one Anyone? Yes.
Oh, what did you say?
How did I do?
Good.
Do we match?
Yes.
Yeah? Does it make sense? Is this okay?
Yes.
Okay. What's next, kids?
Important.
Important vocab. Oh, well, we just have, forget about those, that's not your notes. But our important vocabulary is a linear function. So what's important about it is we can write it in the form y equals mx plus b. You guys will learn to love that. That's kind of like the bread and butter of Algebra 1. You can like learn to graph lines and do things to them. It's a non-vertical line, so it's like slanted or horizontal.
So that was like the first example.
And then, like Lily said, it goes up at a constant rate of change. So that's why it's a straight line. So the hardest part of today is this next part. And you're just given a bunch of equations, right? And we have to figure out which one's a linear function. It's kind of hard. So like they said, this is our form. Y equals mx plus b. So we have to see which ones match that. So for this one,
Wait, can you go back to the vocabulary?
sure.
Okay, there you go back again.
Are you sure? Yeah. Okay. So we have to look at all of these. So what this would look like with numbers, y is always going to be y. Ellen, give me some random number. 12. M is just a random number. X is x. Ezra, give me another random number. 4 plus 4. So this is what it will look like. Now, do any of these match those right off the bat? No. Can we cross any off right away that we for sure know don't match?
The first one.
The first one? Yep, that one doesn't match.
The second one. Or the last one.
The last one doesn't match. Like that has an x squared. We have no idea what that. Like not dealing with that.
The one in the middle. The 2 on the X.
Yep.
Basically, all three. Is the 3x one?
This one doesn't work because our exponent, our variables in the exponent. This is the tricky one. Can I distribute that 6?
Yeah.
Let's distribute that 6. Oh, look how nice that is.
I left it in the generator.
That's okay. I'm glad you found it. What's 6 times x?
6.
6x. What's 6 times -1?
-6.
Now, does this kind of match that form?
Yeah.
So this is the only one that works.
Can I go to the bathroom now?
Yes, thank you for waiting. Okay, so you guys see if you can tell on 5, 6, and 7 which ones work and which ones don't. This is the hardest part. Is it linear or is it not?
Done.
I'll give you a hint. 2 out of the 3 work. And it's kind of tricky, and I'm sorry. 2 out of 3 work.
Done.
You're done? Good job.
Somehow ended up in the person.
What happened? Okay, on 5, what'd you guys put? Linear or non-linear?
No.
Linear.
This one is linear. Look, y equals, there's an imaginary 1 there, x plus 9. That kind of looks like that, right? So this one's linear. What do you guys think on 6?
Not or linear.
This one's so tricky. This one is linear because you could write 3/5 as a fraction, which is just a number, x, and then plus, there's an imaginary 0 there. So that matches this guy, linear.
And then obviously not.
Right, so it has an exponent of 2. That's not linear. That's gonna get, well, eventually gonna match a parabola. It looks like a U. So non-linear.
Are we done?
Almost. We have, I think, one on the back we're gonna do. Okay, let's try a real life example of this. This is where we're at, right? It says the function y equals 15.95x represents the cost in dollars for tickets to a museum. Each customer can buy a maximum of 4 tickets. Consider, we even have on here. Let's make an input and output table. That's just x and y, right?
Mhm.
So what's the most number of tickets I can buy?
4.
4. And what's the least amount I can buy?
1. 0.
0, right? You don't have to buy any. So wouldn't it make sense to plug in 0, 1, 2, 3, 4?
Yeah, good job.
So let's plug those in. You guys make yourself a little T-chart. And now wherever we see an X, we're going to plug in our number. So we're going to have 15.95 times 0. What's that going to give me?
0.
Right, if I don't buy anything, should I have to pay for anything? No. Goose egg.
15.9.
Yep. Anyone have a calculator to help us out? What's 15.95 times 2?
31.9.
31.9? Good job.
Are we supposed to write that down?
At least write down what the answers
And
are.
the third one is 47.85.
Oops.
And the last one is 60.
60?
63.8.
Oh boy. Okay. Now we're gonna graph it. Well, it's easy to label our x-axis, right? How many tickets can we buy?
4.
Up to 4, so we can just count by ones, right?
Mm-hmm.
Now, what would be a good number to count by on the y? We'd get all the way up to 63.8.
Wait, 10.
Tens? Would tens work?
I don't know.
No.
Should we go by fives? Would fives work?
15.
10, 20, 30, 40, 50. Oh, let's go by tens. Let's spread it out a little bit. Or I lied. Let's go by fives. Count by fives.
I want better.
Sure. I'm gonna skip count because I'm gonna run out of space. But count by fives, kids. Count by fives.
Well, I want to get to 16.
Well, they will level up. That's okay. And now we just plot our points. So if I bought 0 tickets, I paid $0, so 0, 0. If I buy 1 ticket, it's $15.95. So just eyeball it about where that would be. 2 tickets, 31. 3, 47. Beautiful. Kind of looks like a line, right?
Yeah. We done?
Almost. Nope. Not on this one. Because can you buy like 1.5 tickets?
Yes.
No.
No. What place is going to let you in with 1.5 tickets? Find a
Central.
place. I want to go there.
Central.
Central will let you in with 1.5 tickets?
I don't know.
No. What would our domain be? This is a good review.
0, 1, 2, 3, 4.
Yep, our inputs. And then our range is our y's, right?
2.95.
All of those guys. Okay, do you guys want to do 1 or 2, or do you want the bottom ones? You guys can pick though.
2.
1.
So it shows it.
1 because it doesn't show. You have to.
Should you do 2?
Yeah.
Yes.
Okay. All right. In Jamaica, there's a maximum number of stories that buildings may have. The height of a building is determined by the number of stories it has. The following table represents this situation. This is a linear function. Can you explain why?
Yes. It's constant with both of the different outputs.
Does that make sense? If we look at our table, I'm going up by 1 on my input, but what am I going up by on my y's?
12.
Yep. Has a constant rate. And then our last question, does the domain have boundaries? So let's think, we're talking about a building, right? So what can't it be? So
Can't be
our domain is the number of stories.
higher than 3 stories. Or
What does that have to be bigger than? Can you have 0 stories?
no.
No, because you wouldn't have a building, right? So it has to have at least 1 story. And then, do we know how many, like what's the maximum that could be? we know though?
No.
Right, so we could say a minimum of 1, so domain, has to be bigger than 1, and then we don't really know what the maximum is, so it didn't really tell us. So we can put a question mark. And now for the range, what's the minimum our range can be? What's the lowest our range can be? Yeah, 12. If I have 1 story, how tall is my building? 12 feet. And then do we know the maximum?
No.
No. I'll look it up. I'll look that up when you guys are working. Okay. Why don't you hop on your Chromebooks? Do an assignment in Big Ideas.